morning. Welcome to Ray Summit. Thank you so much for being here. What a great year for AI. Over the past year, billions of people have encountered AI, and so many of us here have put AI at the heart of our products. Over the next couple of days, you'll hear how Runway and Canva are transforming creativity, what Netflix and ByteDance are doing in entertainment, what Ford and Zoox are doing in autonomous driving, Tower Research in finance, Recursion in drug discovery, Roblox in gaming, and so many more. Over the past year, every business on Earth has realized that AI is central to its strategy. And this community here, building with Ray, has had a front row seat to that. How cool is that? Ray now, thank you. Ray now sees around 1 million unique clusters launched every single month. And my favorite stat, Ray recently crossed the 1,000 contributor mark to the open source project. Many of you are here with us today. Thank you so much for all of your help building this project. It's just been a massive collaborative effort. Now, many of you here are building AI platforms for your companies. So you know how powerful it can be when you can truly enable the latest AI capabilities throughout your organization. Right? Capabilities ranging from rapid iteration to massive scale, spanning classical machine learning and generative AI. Right? If you do your job well, you can enable every team internally to be an AI team. But you also know how hard it is to actually do that. Over the past 6 months, I've chatted with around 100 of you, and one message stood out very clearly. Complexity is blocking us. We're all clear on the potential. We all want to do this, but we're held back by complexity of AI. And my co-founder, Jan, will go into far more detail about the underlying trends driving this, but this is the complexity generated by scaling data. Not just more data, but new data modalities, text, images, video, scaling compute, the proliferation of hardware accelerators, of AI frameworks, more and more AI being used for data processing itself, and growing complexity around post-training and inference time compute. None of this is going anywhere. And actually, it's going to get a lot worse. Of course, the potential is getting a lot bigger, but in parallel, the complexity is getting far worse. And this complexity is actually why we set out to build Ray in the first place. 2016. The aha moment for Jan, Philip, myself, and those of us who originally built Ray was just a similar version of exactly the same problem that we're seeing today. We were researching deep learning and reinforcement learning algorithms for our PhD at Berkeley. And the funny thing is we weren't actually doing research. We were spending our time managing clusters, or cobbling together distributed systems, or wrangling data. We weren't setting out to change AI infrastructure and revolutionize AI infrastructure. We were just trying to solve practical issues that were driving us nuts. But what we ended up building, this Python-first, flexible, seamless scaling approach, everyone we talked to who was serious about AI at the time needed to solve that problem. And so it caught on, slowly at first. The first serious Ray user was Ants Group. They contributed a ton to hardening Ray in production. And today they use Ray on millions of CPU cores, tens of thousands of GPUs for use cases ranging from batch inference to online learning to model serving and more. Uber was one of the next major Ray users, and Pinterest. Those two contributed to fleshing out the data ingest and pre-processing story for training, which so many of us use today and is so important for how we think about Ray's use cases. Today, they run tens of thousands of batch jobs, training jobs every month. But these were early adopters. Ray was still very young. The real inflection point for Ray came with ChatGPT and generative AI. Generative AI took the complexity problem and made it 10 times worse. It also made the potential and the promise 10 times bigger or more, but it made the complexity far worse. And as a consequence, Ray is now powering AI workloads around the world. The work this community is doing is truly bringing AI to life. Next, I'd like to welcome my co-founder, Jan Stoica, co-founder and chairman of Anyscale and Databricks, professor at UC Berkeley, to the stage to talk about the underlying trends driving this complexity and why Ray has become the underpinning of so many AI platforms. Please welcome Jan.
I'm thrilled to be here. This is really a historical moment for AI, which means the need for Ray is only growing. The complexities that leading researchers like Philip and Robert were facing in our lab almost 1 decade ago has become the norm for AI developers at every enterprise today. I know you all feel this. The complexity has become overwhelming. So how did we get here? Let's do a quick run through the modern compute history. As you know, I'm a professor, so I cannot help myself. 2 decades ago, we saw the rise of big data and classic machine learning workloads. These workloads require large clusters to scale data and machine learning processing. However, these clusters are homogeneous, consisting of more or less identical machines. This is a Hadoop and Spark story you all know well. 1 decade ago, we saw the rise of deep learning and reinforcement learning workloads. Machine learning platforms came to the fore. GPUs started to become indispensable. Then, 5 years ago, Gen AI. I'll go into more details on this one, but there are 5 trends to keep in mind. First, scale. The compute requirements to train state-of-the-art model has grown over 5 times every year. This has been driven by the scaling law, which simply says that more data and more compute equates better models. Correspondingly, the cost of training, as you can see here with GPT, has increased more than 1 order of magnitude every 2 years. And it's not only the large language models. The smaller models themselves are much larger than their predecessors. And it's not only training, also inference. Recently, OpenAI released the most advanced reasoning model where the context can be orders of magnitude larger than before. It may take tens of seconds just to answer a single question. This is the beginning of a new scaling era for model inference. Second, massive unstructured data. Text, audio, images, video. These data modalities, which are inherently much bigger than structured data, have become increasingly critical. Video companies building foundation models like OpenAI with Sora, or Genmo and Runway are processing millions of images and videos every day. And Pinterest and Apple, who you will be hear from later today, are processing petabytes of multimodal data to power their Gen AI applications. And it's not just large language models. The unstructured data story also applies to traditional models. Third, sophisticated post-training. Training no longer means just pre-training and fine-tuning, but model pruning, distillation, merging, reinforcement learning, and more. Fourth, AI is used to build AI. By that, I mean that AI is being increasingly used to optimize every aspect of model development, from data preprocessing to synthetic data generation to automatically partition models across multiple GPUs. Each part of the AI stack is itself becoming AI-powered. Fifth, In actual enterprises, we are not talking about just one model. We are talking now about compound AI and agentic systems that involves tens, even hundreds of models, including not only large language models, but also traditional predictive models and more. Compound AI systems only increase the pressure on the underlying AI infrastructure. To summarize, the trends are scale, multimodal data, sophisticated post-training, AI powering the AI stack, and compound AI and agentic systems. These developments put enormous pressure on the underlying infrastructure to evolve. The result, innovation, of course. Above all, hardware accelerators. Just 5 years ago, if I said GPU, we would be largely talking about a single GPU model from NVIDIA. Now, one will be talking about which GPU. We have not only NVIDIA, but AMD, Intel, and every superscalar with its own accelerators. And even when it comes to NVIDIA, now we have H100, A100, A10, L4, and much more. Moreover, to support bigger and bigger models, we are rapidly moving from single server GPUs to ports with hundreds or thousands of tightly connected GPUs. And when it comes to using the resource efficiently, we need to decouple the CPU and GPU allocation to best fit each application demands. In summary, we are witnessing a historic transition from a CPU-centric to an accelerator-centric world. In addition, we are seeing the emergence of AI-focused clouds like CoreWave and Lambda Labs, dozens of new libraries, frameworks, and tools for training and inference. On LLM inference alone, we have not only VLLM, but TRT-LLM and HGLang, as well as a myriad of proprietary frameworks. Finally, there is an explosion of models. Over 1 million models are now available on Hugging Face, over 3 times more since our last summit. So really, the story is simple. The huge changes in the compute needs for machine learning and AI workloads led to very rapid innovation in the infrastructure and tooling, which led to enormous complexity, which in turn led to huge obstacles to AI progress. I know everyone who is trying to build an AI platform knows this story by heart. We call this the AI complexity wall. You hire the best minds in AI, and they spend their days writing YAML files and troubleshooting Kubernetes. So the AI complexity wall leads to wasted resources, skyrocketing costs, and endless timelines to get to production. As Robert outlines, we originally created Ray to break this complexity wall, a complexity wall that is growing bigger and bigger every day. And over the last 8 years, we've had so many conversations with people in the growing Ray community about this complexity wall. And over again, what we've been hearing from you is that we need a unifying layer that sits between the bare metal and the exploding AI ecosystem. We need a software engine, you've told us, that can support any AI and machine learning workload, any data types and model architecture, decouples the allocation of different resource types, fully utilizes every accelerators, and scale from your laptop to thousands of GPUs. And do all this while being able to abstract away the complexity of this infrastructure from the end developer and serve as a flexible and unifying platform for the entire AI ecosystem. The rise of the AI era has made such an engine indispensable to the progress of AI. We are calling it an AI compute engine. An AI compute engine is critical technology for every company that wants to build a future-proof AI platform. The AI compute engine we are here to talk about today is, of course, Ray. Ray has become the AI compute engine of choice for the world's most experienced engineers who are trying to unlock AI in their companies. Now, I'd like to welcome Robert back on stage to walk us through the main elements of an AI compute engine, using Ray as our prime example.
All right. So I'm going to walk through a blueprint of this AI compute engine. And this is a picture we've formed from talking with hundreds of teams who are actually building AI platforms. OK, so I'll walk through the individual components that make up this engine. There are three core problems that the AI compute engine has to solve: managing compute resources, managing data, and executing workloads. So compute resource management, what is this? This is about managing the underlying diversity of cloud providers, hardware accelerators that Jan talked about. What kind of problems do you have to solve? Things like auto-scaling, selecting the right instance types, CPUs and GPUs, handling hardware failures, which are increasingly common at scale. Right? This goes very deep. Data management. Jan mentioned that AI is becoming increasingly data intensive, especially as multimodal models become commonplace. Right? So handling data effectively within this AI compute engine means handling large data. It means leveraging shared memory. It means optimizing data movement through frameworks, communication frameworks like Nickel and RDMA. Workload execution. This is the core scheduling and execution of the actual tasks that make up the AI workload. Scheduling has to be fault tolerant. It has to leverage accelerators. Right? It has to be highly flexible to be able to support the variety of AI workloads that are running on top. Otherwise, you'll end up with different engines for different workloads. Right, so within the core compute engine, you also have workload-specific optimizations for the most important AI workloads. And you have essential observability support, because people are going to spend all their time debugging and debugging performance. So this is the AI compute engine. And the entire compute engine powers the most important AI workloads that we see reoccurring across so many different companies, from data ingest and preprocessing to training to inference. But of course, for those of you building AI platforms, you know that the compute engine is not the whole picture. It sits within a vast ecosystem of tools. Now, without an AI compute engine, AI teams can suffer from serious fragmentation. Think different tech stacks for classical ML and generative AI. Think segregated pools of compute for different workloads, or complex development to production handoffs, or delays supporting new AI frameworks or models. So this AI compute engine is needed to rein in the growing complexity of AI. And that's why we're building Ray. Now, the result of adding an AI compute engine to your tech stack can be dramatic. After moving to Ray, Instacart is training on 100 times more data. Niantic reduced lines of code by 85%. And Canva cut cloud costs in half. These are just a few examples. You'll hear dozens more today and tomorrow. So with the AI compute engine blueprint laid out, I'd like to hand it back to Jan to share our first Ray announcement.
We have been building Ray for nearly a decade now. We started with the assumption that the innovation AI will be relentless. So we tried to design a platform that is flexible enough, that is general enough to easily handle constant advancement in AI. This year, we took a hard look at the rapid changes in the AI world and asked afresh, what is needed for Ray to remain the core AI platforms in every company? We talked to many of you about the top problems you are facing, about what challenges the next 5 years will bring. And based on what we learned from you, we have a number of significant announcements about how Ray continues to evolve. Let's start talking about performance, a necessity in a GPU-first world where models are getting larger and more complex. Consider this simple example of serving a large language model where the model is so big that in order to serve it, we need to split it across multiple GPUs. Now, while Ray is super flexible in general, the price it pays, it's a non-trivial overhead at runtime for tasks which are smaller than a few tenths of milliseconds. And this can be the case here when we generate a new token. Now, here is everything Ray does to generate a single token. Quite a lot. So let me dissect this for you. First, Ray needs to allocate the memory dynamically every time it passes an argument or a result between different nodes. Then, to transfer the data between GPUs on different nodes, Ray has first to copy the data from the GPU memory to CPU memory, a slow operation especially for large data items. Then it needs to transfer this data over standard slow network, and finally copy again data from the CPU memory to GPU memory, another slow copy. At the same time, the head node needs to pass the references to arguments and results via a bunch of remote procedure calls. So a lot of overhead to generate just one token. To reduce this overhead, we are introducing the first new major API in Ray over the last couple of years. It is called compiled graphs. This API is still experimental, so this is a preview. And we invite you, the community, to help us evolve it. Our goal here is to run tasks which takes less than 10 milliseconds with less than 1% overhead. So how do we do this? In a nutshell, compiled graphs is a static task graph with Ray-like API, which allocates resources once at the beginning and reuses resources across multiple executions. Going back to our examples, we created a static graph consisting of two actors, each actor handling a model partition. We compile this graph and then instantiate it. As a result, Ray pre-allocates all the resources and reuse them across multiple token generations. In particular, it pre-allocates static buffers for all arguments and results, so no need for dynamic memory allocation. Since we have pre-allocated all these buffers, there is also no longer need to pass around references to arguments and results. And finally, compiled graphs set the peer-to-peer communication between GPUs and transfer data directly via NVIDIA Nickel, for instance. So no longer slow CPU to GPU memory copies or transfer over the slow network. So what does this mean for basic operation? Well, compiled graphs are 17 times faster for GPU to GPU communication when GPUs are on the same node, 2 times faster when GPUs are on different nodes, and 13 times faster for scatter and gather operations on the same node. But what does this mean for practical AI and machine learning applications? We've actually been using compiled graphs on both inference and training workloads, and we've seen some immediate benefits. For example, we use compiled graphs to optimize LLM inference by adding both tensor and pipeline parallelism. By doing so, we increase the throughput for batch inference by 15%. This is already in production today. But that's not all. We also use compiled graphs to optimize training for multimodal architectures. By collocating test encoders to cheaper GPUs, we increase throughput per dollar by 40%. All told, we believe compiled graphs is a major step towards future-proofing Ray as a high-performance compute engine for the AI era, and we can't wait to see how the community is going to use it. And now, back to Robert for the next Ray announcement.
Thank you. All right. So if compiled graphs is Ray's answer to our new GPU-centric world, Ray data is the answer to the explosion of unstructured data that we're seeing. Unstructured data preprocessing is the single fastest growing use case of Ray that we've seen. You'll hear about it throughout this conference from Ford, ByteDance, many others. So what's special about these workloads? Well, unstructured data preprocessing and AI data preprocessing combines regular processing with inference. It requires CPU compute as well as GPU compute. And it's both GPU intensive and data intensive. So these are brand new systems requirements. Ray data handles everything from ingestion, ingesting the data in a streaming fashion, last mile preprocessing, and streaming the data into training. Many of you are already using Ray data in this fashion. I'm very excited for everyone else who's about to use it. If you're asking yourself, why do we need another big data processing system? The answer is very simple. Today's big data processing systems, like Spark, Flink, Hadoop, are CPU-based. And they operate best, they work best when they're operating on structured tabular data. Okay. AI workloads are GPU-centric, and they often require unstructured data. So this is a brand new regime, right? SQL is not going anywhere. Structured data is not going anywhere. But organizations are increasingly going to use AI to read their data, to reason about their data, and draw conclusions. And so data processing is fundamentally becoming an AI-driven and GPU-driven workload. Right? And today's CPU-based systems simply aren't going to work for those use cases. So we've tripled down on making Ray data excellent. I'm thrilled to announce today that Ray data is now generally available. Many of you are already using it, and I'm very excited for everyone else to try it out. Again, congratulations. Thank you so much. So like I said, SQL is not going anywhere. But we expect companies to see massive performance wins and benefits when switching to Ray data for unstructured and AI data processing. Just to give you a couple examples, Pinterest sped up batch GPU jobs by 4 times. They'll be talking in this conference. Instacart will talk about 5x cheaper batch AI processing. But most impressively, Amazon migrated an exabyte scale data processing workload from Spark to Ray. When they did that, they cut costs by 82%, saving $120 million every year. That's extraordinary. All right. Finally, I want to talk about stability. In terms of what actually matters, reliability at scale is at the very top, especially for many of us here, where AI is increasingly the key to our competitive differentiation. Right? If that's the case, we need infrastructure we can rely on. That's not going to introduce risk or introduce delays as we ship AI features faster and faster. So with that in mind, our team has been laser focused on improving the core stability. We've quadrupled the number of nodes supported in a Ray cluster to 8,000. We now ship weekly Ray releases to get fixes and features in the hands of our users faster than ever before. And over the past year, our team fixed 1,700 different reliability and usability issues. This has been huge. The pace is only increasing, and we have massive plans for the rest of this year. So congratulations to the team. This has been a year of huge change at Anyscale. The biggest is that my co-founders, Jan, Philip, myself, decided to bring on a new CEO to lead our next stage of building and growth. I'm very, very excited to introduce him to you today. Kirti Melkote is a builder. He built Aruba from zero to a massive customer-obsessed business. He's somebody who understands the true power of community and someone who joined Anyscale because of the incredible growth of the Ray community. So please welcome to the stage, Kirti.
Thanks, Robert. Stay with me. Hello, everyone. So excited to be here at this amazing event. Let me first start off with a huge thank you to Robert on behalf of all of you for starting the Ray project along with Jan and Philip, and for your incredible stewardship of the community. Thank you, Robert.
Thank you so much.
This community was one of the primary reasons why I joined Anyscale. The work you do and the impact you're making in this new world of AI is so inspiring to see that I simply had to be a part of it. My career, I've entirely focused on building infrastructure in each of the major technology waves, starting with the internet, followed by mobile, and then the cloud. In each wave, it took an entirely new generation of infrastructure to power it. And AI will be no different. AI infrastructure that can process massive amounts of data, train and tune models of all sizes, and serve them at scale is the need of the hour. And this is what motivates us at Anyscale. This opportunity to build infrastructure that empowers you to scale your AI applications is what motivates us. To do this well, we must commit ourselves to 3 key priorities. The first one is Ray itself. We need to continue to build Ray to be the most powerful AI compute engine in the industry. You just heard from Jan the release of compiled graphs, a major new update to Ray to enable GPU to GPU communications. You heard from Robert the general availability of Ray data and our commitment to keeping Ray the most stable, reliable, and performant AI compute engine in the industry, period. Priority 2 for us is this community, all of you. We need to continue to foster and grow this community, and we are today already 50,000 strong, which is an incredible feat. But we need to be 10 times the size if we are to meet the needs of this growing AI wave in front of us. And to do that, each one of you in this room is the key. It is very clear you've been super engaged in the community, helping each other. And I just wanted to name a few particularly prolific contributions over the last year. Teams at Intel, Amazon, and AMD have added support for their accelerators. Google, Microsoft, Huawei, Ant Group, Workday, eBay, and ByteDance, and the list goes on. You've all made significant contributions to KubeRay, RayCore, RayServe, and the observability tooling. I just wanted to take a moment to recognize all your efforts and for your significant contributions. Thank you so much. Our third priority is we want Anyscale to be your partner to both de-risk and turbocharge your AI initiatives. In my first weeks here at Anyscale, as I met with a number of you, it became very clear to me that Ray is core to your work, and you want Anyscale to be an integral part of it. And it was also very clear that only a small handful of companies have the resources that it takes to build an AI platform around Ray as your compute engine. So to achieve this objective, we've built an enterprise-class managed Ray service that allows you to deliver a fully unified AI platform. Anyscale leaves all your data in your compute estate and adds a thin control plane on top that you as platform engineers and AI/ML practitioners can interface with to really get the best out of Ray. And to understand what we've added in Anyscale's managed Ray service, let's refer back to the blueprint that Robert talked about. So here's what's in Ray, and here's what we are adding in Anyscale. First, Anyscale brings together all your compute resources in a unified compute pool. Next, a truly optimized Ray runtime that is up to 6 times more performant than Ray open source. You'll hear a lot more about this shortly. Third, we've added an entire governance layer that every enterprise needs to maintain control over AI sprawl and runaway spending. And lastly, an end-to-end suite of developer tools and production services to create and build and scale AI applications. Next, we are going to hear about a number of major feature enhancements to the Anyscale platform designed to make Anyscale work for you and optimize your top workloads. To talk through these announcements, let me now welcome Anyscale's Head of Engineering, Jaikumar Ganesh, to the stage.
Thank you, Kirti. Excited to be here. How's everyone doing? All right, let's try something fun here. I would like everyone to stand up, stretch up your arms and legs. On a count of 3, 2, 1, we are going to say Ray Core. Ray rocks, actually. 3, 2, 1. Okay, let's do it again. Louder this time. 3, 2, 1. Great. You know what? I actually agree with all of you. Ray indeed rocks. Please take a seat. So Kirti talked about optimizing your top workloads. Robert earlier showed the AI compute engine. While Ray does abstract away a lot of the complexity of the underlying distributed compute infrastructure, it absolutely does not hide these away from you. This is not an overly simplified serverless solution. We have carefully taken knobs, levers, and pedals and exposed it to the serious drivers. This is a Formula 1 compute engine. We have taken this compute engine, worked with all of you to optimize your workloads. And today, we are excited to announce Anyscale's hyper-optimized version of Ray. We are calling it RayTurbo. To take a deeper look on how RayTurbo does on a data processing workload, I would like to invite Richard Liao, co-creator of Ray and product manager at Anyscale, onto the stage.
Thanks, JK, for the introduction. Let's talk about RayTurbo. To start, RayTurbo is fast. We ran a workload comparing RayTurbo to open source Ray data. And this workload is really simple. Read some data from storage and iterate over it, similar to the data ingest phase of a distributed training workload. And what we did was we scaled the data set from 10 gigabytes to 1 terabyte, and we measured the time it takes for the first output to be returned. Now, compare it to open source Ray. The Anyscale RayTurbo implementation is able to perform up to 4.5 times faster. That's really, really fast. Now, RayTurbo is not only super fast, it also slashes your AI costs.
So batch inference for LLMs is a critical workload for all of you. So let's see how RayTurbo does on costs here. Here, we have taken an 8B model, run it on a data set of requests, 2,000 input and 100 output tokens with no shared prefixes. We compared Anyscale's RayTurbo with OpenAI GPT-4o mini batch pricing and Bedrock pricing. We noticed that RayTurbo is 2.2x cheaper than OpenAI and 2.9x cheaper than Bedrock batch pricing. Of course, in batch LLM inference, many times the same prompt is shared across multiple requests.
And in such situations, unlike OpenAI and AWS Bedrock, Anyscale can take advantage of prefix caching. As a result, we can see a much greater cost differential. On the same workload, if we assume a large shared prompt, we see that the Anyscale RayTurbo solution for this workload comes out to be 6.1 times cheaper than AWS Bedrock, even with its batch pricing. And here's the biggest kicker. These numbers were achieved without H100s or A100s. They were generated on widely available compute, namely L4s and L40s. This is going to be a huge game changer for LLM use cases across the board. Now, RayTurbo doesn't only slash costs, it also dramatically improves workload scaling. So in serving workloads, scale-up speeds matter a ton. To illustrate RayTurbo's capabilities in this situation, we compared open source KubeRay with Anyscale RayTurbo, and we measured the time it took to start up a 70 billion parameter model from scratch. Now, while the open source solution takes nearly 10 minutes, the Anyscale solution is able to scale up the replica in about 100 seconds, and less than 1 minute is spent to load the model itself. Together, that's a 5.1 times end-to-end improvement over the open source KubeRay and open source defaults. That's really, really impactful.
So we showed that RayTurbo is fast, and it makes your batch inference workloads and serving workloads scale up really quickly. All of these are impactful numbers that have an impact on your bottom line. But there are a lot more examples where RayTurbo really shines. So let's look at some of them. We saw that we can lower costs on spot instances for workloads like elastic training. We reduce the number of nodes required using techniques like replica compaction for your serving workloads. And we are seeing higher QPS with an optimized version of RayServe. All of this on RayTurbo, available exclusively to Anyscale customers. We also work with all of you to improve the stability and reliability of the system. It kind of makes it a no-brainer to use Anyscale, the best place for using Ray and getting the power and benefits of Ray. Kirti talked about deploying in your environments and your work resources. To talk more about that, I would like to invite Dominic and Ife, infrastructure leads on Anyscale, onto the stage.
All right, JK mentioned F1, but let's take this analogy one step further. Winning in F1 comes down to 4 key factors: power, speed, efficiency, and control. We chose this metaphor for a reason, because if you are an AI platform leader, you're typically balancing between these attributes for yourselves and for your teams. What do I mean? Power. You need to put all the horsepower you have behind your developers. Speed. You need your developers to drive fast. The race for AI is happening at breakneck speeds, and you must remove all roadblocks. Efficiency. You want to take full advantage of every resource that's available, firing on all cylinders, but not burning through the gas. And finally, control. You need to give your developers guardrails, because these cars are insanely fast and very pricey. We're going to dive into each one of these.
Let's start with power. At Anyscale, we have been building a turbocharged engine aimed at getting the most out of cloud machines on AWS and GCP. However, the last years have shown while the clouds are powerful, they are not unlimited. Many of us here are very familiar with this error message. Yes, cloud might have capacity issues, and clouds are certainly not cheap. We've seen companies of every size rethink their cloud strategy, many of which decide to go invest back in on-prem specialized machines. What if we could take the power of these on-prem machines and make them available to our scientists and engineers, just like the clouds? So with this vision in mind, we have built the Anyscale machine pool. Machine Pool makes it easy to create hybrid Ray cluster that span both the cloud and on-premises, taking any machines in the world to amp up what's available in the cloud. And of course, you get all the optimization of RayTurbo, JK and Richard just talked about, out of the box. And there you go, power.
Machine Pools takes our VM offering and shifts it into overdrive, but it doesn't unlock compute for everyone. We know that the developers and companies pushing the boundaries of AI on Ray, you all here today, have largely been deploying on top of Kubernetes with KubeRay, by far the most common pattern we see. So this year, we thought to ourselves, how do we take Anyscale, our platform, our optimized Ray, and deliver it to you on top of your Kubernetes clusters? In that vein, we're thrilled to announce the Anyscale operator for Kubernetes. The Anyscale operator lets you supercharge Ray on your Kubernetes clusters, letting Anyscale deal with the heavy lifting of configurations, dependencies, and security of Ray. The Anyscale operator was designed to be highly customizable, meaning Anyscale can be a part of your existing AI platform. But we're not doing this alone. We're thrilled to announce our launch partners for the Anyscale operator for Kubernetes. So whether you're on Amazon EKS, taking advantage of Trainium and Inferentia, whether you're on Google GKE, leveraging their TPUs, on Azure AKS, or even Oracle Cloud Infrastructure, we can work together to bring the best of Anyscale, Ray, and these providers to you. So thank you very much for our launch partners. There's much, much more to come. So, to make this super clear, whether you're running on cloud-native VMs, on-premises, or on Kubernetes, Anyscale can turbocharge your Ray clusters anywhere in the world.
Now let's switch gears and talk about speed. I'm sure many of us here have sat through the pain of waiting 5, 10, 20, even 30 minutes for a large cluster to spin up, and then having the realization we need to do this over again just to try a different GPU type. I know this entire process is very slow, it's very frustrating. It does nothing but holding us back. So to solve this problem, we have built the Advanced Instance Manager, capable of launching massive Ray cluster extremely fast. We're talking launching thousands of nodes in under just a minute. It also scales up faster than open source Ray, speeding up your iteration cycle so you don't have to spin your wheels. So to take this a step further, we're also introducing the automatic workload selection feature. This is a feature that allows you to specify your resource requirements, like your accelerate type, directly in your Ray code instead of in a separate configuration file. And then it will automatically choose the most cost-effective instance type for you. Overall, the Advanced Instance Manager lets you focus on your AI application instead of wasting your precious time thinking about the underlying machines. So, saving time, saving money, going fast.
Let's turn to efficiency. The cost of AI is real. Being able to launch clusters quickly and reliably on the most cost-efficient infrastructure saves time, money, and your developer sanity. Which is why we built the Advanced Instance Manager to be aware of every region and availability zone. We're able to maximize availability while also optimizing for spot utilization. With a single flag, one flag, we can scan an entire region for spot capacity before looking for on-demand. And when spot becomes available again, we can seamlessly migrate your workload back to spot. So, as capacity changes, as your workload scales, Anyscale is consistently landing your AI applications on the most cost-efficient infrastructure. Lastly, control. Backing all of this is the Anyscale Governance Suite. The Anyscale Governance Suite gives you everything you need: resource quota management, budgets, visibility, telemetry, everything you need to stay friends with legal and finance. Very important. But seriously, we want every team to become an AI team, and the Anyscale Governance Suite has you covered. So to recap, today, we are launching features that gives you the full power of all of your resources in your compute estate, on cloud, on-prem, and on Kubernetes. We're releasing radical speed and efficiency so your engineers can rapidly unlock the full potential of this estate. And finally, the fine-grained control you need to maintain your sanity as a platform leader. Because yeah, these cars, insanely nice. Now, to take us through the life of a developer on Anyscale, let's please welcome to the stage Goku and Angelina.
So, Goku, I know you have that flight to catch tonight for your honeymoon.
Yeah.
You know that image identification application you started to build?
Yes.
You're going to need to finish that before you go.
Right before my honeymoon? All right. Well, I started developing on this Anyscale workspace here, and you've literally caught me right in the middle of total dependency hell. I have no idea what compute my workloads need, and I don't even know how to get started with debugging any of my workloads. I'm totally screwed.
Relax, breathe. Walk me through these one by one.
Okay, well, for one, I forgot to install a really important dependency, and now I have to go through each of my workers one by one, and who knows how many other dependencies I forgot. I'm going to have to make a phone call and probably catch a later flight now.
Hold on. Isn't that why we bought Anyscale? Just do the pip install on the console, and now your head node and all your workers that you might spin up later on will automatically have your dependencies ready to go.
Whoa, okay, that's really cool. And I feel like this is going to save me a ton of time. But I feel as like a developer, I know how to make things, like these workloads, but I have no idea what compute I need. I just don't even know where to get started with it.
Don't worry about it. We toggled the auto-select worker nodes, so Anyscale will spin up the right number of workers, execute the workload, and spin them back down when they're done.
Okay, that is really cool. And I feel like this is going to save us a ton of time and money. Hopefully money that can be applied towards my next bonus.
Haha, not.
Okay, worth a shot. All right, more workers sounds great, but I feel like with more workers, doesn't that also mean more problems? I mean, what if I experience an error here? How am I going to know where to look and debug? That's going to take me forever. Let me actually make that phone call and probably cancel the whole trip right now.
Stop panicking. We just need to check out the Unified Log Viewer on the Logs tab. This page consolidates the logs for all the workers and other distributed components. That means we can find the exact root cause error right away.
Okay, I love this. But I feel like my wife is going to love this Unified Log Viewer even more than me. I mean, so much more time back in my life. All right, I think we're pretty good here. I'm able to ingest a little over 20,000 images, and they're getting embedded in index now. So am I good to go? Can I head out?
Oh, one more thing. Let's get this up and running for online inference.
Online inference, you mean production?
Of course.
No, that's actually going to take me forever. I need to rewrite all of this from development over to production, not to mention actually getting this up and running as a service that can scale up and down. It's just not going to happen today. So let me actually make that phone call now, and probably to a divorce lawyer at this point.
Stop being dramatic. A single line to launch all of this as a service, and we're done.
Okay, I'm actually going to name this Anyscale Save My Marriage. And wow, okay, this is awesome. In literally 3 minutes, Anyscale helped me get out of my total dependency hell, helped me find the optimal compute I need. We're debugging on top of literally thousands of workers all on one view, and now it looks like we're rolling out to production. And it looks like it's spinning up. I'm actually going to head out now, so I'll catch you later.
Woohoo! Have a good one. Whew! Looks like Anyscale saved a marriage.
Wait. I'm sorry. My flight was actually delayed,
and it looks like I have a lot more time now. So I'm just going to relax here for a little bit and
Sure.
yeah, take my time.
Great. Well, while you're here,
yeah.
let me tell you about the project you'll be working on after you get back from your
All right,
honeymoon.
let's hear it.
It's an LLM workload with very large data and models.
No, no. Our platform is made for classical machine learning, and we just got it running for deep learning use cases. LLMs are a completely different story. There's no way this is going to work. I mean, for starters, for fine-tuning these models, where are we going to get the compute? We can't even find anything. And then serving these models in an efficient way, not possible. If this is what I'm coming back to, I might just stay on my honeymoon forever.
Enough with the hyperbole. Look, Anyscale has a new LLM suite specifically for this.
OK, let's see how comprehensive this is. What models can I use? Can I use whatever I want?
We can use any model on Hugging Face.
OK, what about different fine-tuning tasks, like for classification or instruction tuning or preference tuning?
Yes, to all those, including distillation.
OK, but what about actually doing the fine-tuning, though? I feel it's so hard to find A100s or H100s these days, and these models just keep getting bigger.
Don't worry about it. We can train on smaller, more available hardware like A10s, and Anyscale takes care of all the distributed work for us.
OK. What about serving, though? Can I serve thousands of small LoRa adapters on top of the same base model?
And optimize for latency or throughput.
OK. All right, this sounds really cool. What do I have to install? A bunch of new stuff for this, or?
Absolutely nothing. It's the same Anyscale platform we used before.
OK, this actually sounds like a ton of fun, so I may just get started on this right now. OK.
Oh, no, you don't. Go.
Are you sure?
Catch your flight.
All right.
Yes.
Oh, my work laptop.
And don't forget your work laptop.
Thank you. See ya.
Wasn't that fun? Goku, go enjoy your honeymoon, and don't forget to send us some photos. All right, so let's recap all the announcements. We introduced RayTurbo, which makes your workloads go faster and cheaper. We talked about Anyscale machine pools and Anyscale support for Kubernetes, which lets you deploy your workloads in your environment using your resources. We showed how ML application development can be effortless with features like automatic worker nodes and advanced instance manager. Anyscale Governance Suite will make your finance team smile. And finally, and most importantly, we showed that we can do all of this without compromising on end-to-end developer experience so that Goku can enjoy his honeymoon. I'm so excited to see what you all will build. I feel like going, developers, 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 but I'll keep the chant for some other day. So with that, I would like to welcome back Kirti on stage.
Thanks, JK and team. So exciting to see all that amazing work. Building out Ray as the premier AI compute engine and Anyscale as a unified AI platform. We can't wait for you guys to try some of these exciting new features out. But so much of the power of the story is about the ecosystem. Ray and Anyscale are a platform, and for a platform to work, it needs incredible partnerships. At the technology level, this means connectors to Databricks and Snowflake. It means integrations with MLOps tools like weights and biases and MLflow, orchestration platforms like Airflow, DevOps tools like Datadog, and many more. Anyscale integrates with the entire AI ML ecosystem, and we invite new partnerships. Please let me know if you're interested in partnering with us. I'm also glad to announce that Anyscale is now available through the AWS and GCP marketplaces. And we are also very excited about having every major cloud as a launch partner for our Anyscale operator for Kubernetes. And on this note, and so importantly, an elevated thank you to all our sponsors. Thank you to our platinum sponsors and the many other sponsors that you see on the screen. We would not have been able to host this Ray Summit without you, so thank you very much. We really appreciate it. I'm so excited to hear later today from Anastasis and Mark Andreessen, tomorrow from Brandon Leonardo from Instacart, and the almost 200 speakers over the next 2 days. Our team is available at the Anyscale booth in the expo hall to take your questions, give you a test run of all the new features that you heard about today, and provide guidance to all of you as you explore your AI workloads. Don't hesitate to reach out to me directly if you want to talk through your AI journeys with me. Finally, I'd like to close by saying how inspiring it's been getting to know this community and all the amazing work that you do. There's just so much energy here. Ray has truly become the premier AI compute engine for the industry, and we have added many new capabilities in Anyscale to make it truly enterprise ready, and I encourage all of you to look deeply into using it to supercharge your AI efforts. Most importantly, what you're building has huge potential to genuinely change the way we live. So thank you very much for building with Ray.